In question 1, I have a cylinder and I'm going to put some water in, and the cylinder will not fill up. It will only go up to a specific height, and that's what I'm trying to find. So that's the level of the water when we put the 1.5 liters in the cylinder. Note that the water takes up the shape of a cylinder, but with a height of less than 10. So the first thing I'm going to do is convert the 1.5 liters into centimeters cubed. 1.5 liters, and then to do that I will need to multiply by 1000. So that's 1500 centimeters cubed. And then volume of the cylinder is pi r squared with an unknown h. So 1500 equals to pi 8.2 squared times the unknown h. So my h will be this over pi r squared, and h comes out to be 7.1 centimeters to 1 decimal place. Note the value 10 has not been used at all in my calculations. For question 2, there are two approaches. You can either work with the interior angles, in which case the formula for the sum of the interior angles is the following. Now, since it's a regular polygon, then each interior angle is n minus 2 times 180 over n, and this must be 162. I can cross multiply and then expand. So I can solve this and get 18 n equals 360, and comes out to be 20. Now, if you're going to work with the exterior angles, the sum of the exterior angles is 360. And then, since I have a regular polygon, each angle is 360 over n, and this is equal to 18. The reason this is 18 is because an exterior and an interior angle, they always add up to 180. So each exterior angle is equal to 180 minus the interior, which will give me 18. And then if I solve this equation, I will get n is equal to 20 again. I'll start question 3 by listing the sets A and B. So set A includes the elements 12, 14, 16, 18, and 20. Set B has 12, 15, and 18 as its elements. Now the first one is A intersection B. Those are the elements that are in both A and B. So I've got 12 and 18. The second one, A union B, are the elements that are either in A or B or both. So I've got 12, 14, 15, 16, 18, and 20. And then for the last part, A dash. Now these are the elements that are not in A, but are in the universal set. So exclude all the elements of A. What is left is A dash. So I've got 11, 13, 15, 17, and 19. For question 4, I'll bring the minus 13 to the right and the 8x to the left. So I have minus 4x equals 30. So x is 30 over minus 4, which is minus 15 over 2, or minus 7.5 as a decimal. In part A, I will divide 720 by prime numbers. So let's start by dividing by 2. You get 360 by 2, 180 by 2, 90, again by 2, that's 45. Now divide by 3, you get 15, 3 again, you get a 5, and divide by 5 to get 1. So the answer would be 2 to the power of 4 times 3 to the power of 2 times 5 to the power of 1. You don't have to write the power of 1. Now in part B, it says find the smallest whole number that 720 can be multiplied by to give a square number. Now if I want the number to be a square number, it means that all powers must be even. Now the only number that doesn't have an even power is 5 because its power is 1. The other two are fine, so I need to multiply by 5, so the power of 5 becomes 2, which is an even number. In question 6, I have a percentage increase of 8%, which means that the multiplying factor is 108 over 100 or 1.08 as a decimal. So I have 4.25 as a starting price times the multiplying factor, which will give me 4.59, which is the new price. Now for part B, my unknown price, if multiplied by the multiplying factor, will give me the final price. So to find the original price, I'm going to take the final one, divide by the multiplying factor, and this will come out to be 8.75. In question 7, I have an isosceles triangle. The height splits the base into 2 equal parts. Let's call half of that as x. And to find x, I'll use Pythagoras theorem. So I've got 7.5 squared is equal to 6 squared plus x squared. So x squared is 7.5 squared minus 6 squared. X comes out to be 9 over 2. Remember to take the square roots. So BC, which is the base, is equal to 9. So the area is equal base times height over 2, which is 9 times 6 over 2, comes out to be 27 cm squared. For question 8, before we begin, let's remind ourselves of the mean formula. In this formula, when we write sigma x, what we mean is the sum of our observations. Now, I'm going to split my page into 3 parts. 1 part for the 10 people, 1 for the 3 people, and 1 for the 7 people. Now, using the formula for the mean above, for the 10 people, I have 79.2, which is the mean, equals to the sum divided by 10. So the sum comes out to be 792. For the 3 people, I will repeat the process. 68, which is the mean, is equal to the sum of the 3 people divided by 3. So the sum of the 3 people is 204. And finally, for the 7 people, the sum will be equal to 792 minus 204, which comes out to be 588. So the mean for the 7 people is equal to the sum divided by 7, which is the number of people, and the answer comes out to be 84 kilograms. For question 9, because of the division, I will subtract the 2 powers. So I'm going to have t to the power of 6. In question B, because of the multiplication, I will add the two powers, so it's w to the power of 12. And in part C, I will split this. It's going to be 5 to the power of 3, x to the power of 3, y to the power of 6. That's when I multiply my powers. So it's going to be 125 x to the power of 3, y to the power of 6. In question 10, I've got 22 meters per second. I can write this as 22 meters over 1 second. And now I need to convert to kilometers per hour. Now the 22 meters needs to be divided by 1,000, so they become kilometers. And the 1 second needs to be divided by 60 and then 60 again, so I can convert them to minutes and then to hours. So it's a total of 3,600. Now they are in hours, and if you do this on the calculator, you will get 79.2 kilometers per hour. For question 11, I have this information. Now t is equal to 15, c is equal to x. 3 years ago, t was 12, c was x minus 3, and 3 years ago the ratio t to c was 2 to 7. So I've got now 12 to x minus 3, and if I cross multiply, I'm going to get 2 times x minus 3 is equal to 12 times 7. So x minus 3 comes out to be 42, x comes out to be 45. In question 12, I have a cuboid that will be placed on a table. There are 6 faces that come in pairs. The biggest face is 5 by 4. The smallest face is 4 by 3. And the other face is 5 by 3. So let's find the area of each face. 5 times 4 is 20. 5 times 3 is 15. And 4 times 3 is 12. Let's color code these as well according to our shape. Now the pressure is equal to the force, which is constant, divided by the area, which means one of those 3 numbers. And if I want P to be as big as possible, I'm going to divide 105 by the smallest of those 3 numbers, which is 12. So this comes out to be 8.75. And Q is the smallest possible pressure. So it's 105 divided by the biggest of these numbers, which is 20, and this will give me 5.25. So if I subtract P minus Q, that's 8.75 minus 5.25, and the answer comes out to be 3.5. For part A union B is this region here. The dash takes the complement, so basically it's everything except this region. So it's either this one or the region outside. And then I have intersection C. C is this region here. And since I have red intersection blue, I need the region that is both red and blue. So it's this region here. For part B, I need to describe the shaded region. Note that this is the intersection of the union of D and E and the set F, so it's D union E intersection F. For part A, I'll just use the information given to complete the tree diagram. Now, since this number is 0.3, this one has to be 0.7. They should add up to 1. Now, if he goes by bus, probably he'll be late is 0.2. So the one below should be 0.8. So they add up to 1. Similarly, if he walks to school, the probability he'll be late is 0.1, which leaves a probability of 0.9 exactly below. Now for part B, first I'll calculate the probability of being late. Now he can't be late either if he goes by bus or if he walks. So I need these two probabilities, and to find those probabilities, I will multiply 0.3 times 0.2, that's 0.06, and the one below is 0.7 times 0.1, 0.07. And then I'm going to add these two, so 0.06 plus 0.07 will give me 0.13. And to find the expected number of days he'll be late, I'll multiply 200 by this probability and I will get my estimate. In this question, I have line L1 with equation 2y equals 6x minus 5, which I can rearrange as y equals 6x over 2 minus 5 over 2, or if I simplify, that's y equals 3x minus 5 over 2. And the gradient of this line, M1, is equal to 3. Now, line L2 is perpendicular to line L1. So if I multiply the two gradients, I should get minus 1. So 3 times M2 is minus 1, which means M2, the gradient of line 2, is minus 1 over 3. And I also know that this line passes through point 9 minus 1. So now I can use these three numbers, the gradient, the x, and the y coordinates, to find the y-intercept. So y equals mx plus c, which will give me minus 1 equals minus a third times 9 plus c, and c comes out to be 2. So my equation is y equals minus a third of x plus 2, and I need to get x and y on the same side. There is no indication whether a and b, c should be integers. So a third of x plus y equals 2 would be a valid answer. For part A, to find an expression for the velocity, I'll need to differentiate. So I need ds dt. So 4 times the power, which is 3, is 12t. Reduce the power by 1, you get squared, minus, and then you have 6 times 2, that's 12t to the power of 1, no need to write it, and then you have 5t with the power of 1, it becomes just 5 without the t, and that's the expression for the velocity. In part B, it asks about acceleration, and the acceleration is the derivative of the velocity, so I'll need to differentiate again. So 12 times 2 is 24t to the power of 1 minus 12, and this should be equal to 6 according to the question. So let's solve this. It's going to give me a value of t, which is 0.6. 0.75. I'll start this question by noting that 24 passengers are between 40 and 60, which means that in this class, the area is equal to 24. So 20 times the height of that bar is equal to 24. 20 is the base of that rectangle. So the height is 1.2. So I can label now here as 1.2. And this can help me scale the y-axis as follows. Now the idea is to find the total area of the histogram. I can organize my calculations on a table if I want. You don't have to do it, but it helps me explain my working. So here is the table I'm going to use. The width of each bar is just the upper bound minus the lower bound. So for the first one is 10 minus 0, which gives me a 10. I've got 20 minus 10, which is also a 10, and so on. So I can complete this column now. The height of each bar can be read from the scale here. So for the first one is 0.4, second one is 1.8, and I can now complete the table. And finally, I can find the area of each bar by multiplying the width times the height. So I have a 4, 18, 32, 30, 24, 16, and this will give me a total of 124. And since the area is equal to the frequency, I have a total of 124. Now you don't have to do a table, you can just do the multiplications and still get the correct answer. For part B, I want an estimate for the probability that a person chosen at random is older than 55 years old. Note, from 55 to 60, I am selecting a quarter of this group. This group has a width of 20. From 55 to 60, I get 5. So 5 out of 20 is a quarter. And since I have 24 passengers, a quarter of 24 is equal to 6 passengers. Then in the group 60 to 80, I have 16 passengers. And if I add this up, I get 22. So my answer would be 22 out of 124. Or you can simplify this one to 11 over 62. I'll start part A by keeping the first bracket the same and expanding the last two brackets. So I have x plus 2 and then 2x squared minus 14x plus 3x minus 21. This simplifies to x plus 2, 2x squared minus 11x minus 21. And then I'm going to expand these two brackets. So I have 2x cubed minus 11x squared minus 21x plus 4x squared minus 22x minus 42. And the final answer is 2x to the power of 3 minus 7x squared minus 43x minus 42. I will start part B by cross multiplying. So p squared times 2m minus y equals x plus m. I will then expand the left hand side to m p squared minus p squared y equals x plus m. Then I'm going to collect all the m terms on the left and everything else on the right. So 2 mp squared minus m is equal to x plus p squared y. I'm going to factorize the left-hand side. I'm going to take m as a common factor. So I'm left with 2p squared minus 1. The right-hand side stays the same. And finally, I will finish off by dividing by the brackets. And this is the final answer. Note that if you did a different rearrangement at this step, you would have gotten m is equal to minus x minus p squared y over 1 minus 2p squared. This is also correct. In question 19, I'm given two pieces of information, one of them about the 25th term and one of them about the sum of the first 30 terms. So I'm going to create an equation for each one of those, solve them simultaneously, find the first term and the common difference, a and d, and then use those to find the 16th term of the sequence. I'll start using the nth term formula, which says the following. So I have 44.5 equals a plus 25 minus 1 times d. So 44.5 is equal to a plus 24d. And then for the second statement, I'm going to use the sum formula. So 765 is equal to 30 over 2, 2a plus 30 minus 1 times d. So 765 is equal to 15 times 2a plus 29d. I will divide this by 15. So I will get 51 is equal to 2a plus 29d. And then I'm going to solve these two equations simultaneously. I will substitute the first one. Once I rearrange, get a on its own, 44.5 minus 24d. And I will substitute this one into the second one. So I'm going to have 51 equals 2 times the expression from the left plus 29d. Then I'm going to expand. That's 89 minus 48d plus 29d. I can bring the 89 on the left, so that's minus 38 equals minus 19d. So d comes out to be positive 2. And then I can use this equation to find the value of a. So a is equal to 44.5 minus 24 times 2. A comes out to be minus 3.5. So now I can use the nth term formula from above to find the 16th term. So 16th term is equal to, that's a plus n minus 1 times d, and this will give me 26.5. For question 20, I need to find a to the power of 3 over 2. So this is 25 times 10 to the 14n, the whole thing to the power of 3 over 2. Because I have multiplication, I can split this into 25 to the power of 3 over 2 times 10 to the 14n to the power of 3 over 2. The first one gives me 125 times, and then the second one, I will just multiply the two powers, and I'm going to get 21n. This is a valid answer, but it's not in standard form, so I'll need to divide the first number by 100, so it becomes 1.25, and to balance things off, I'll need to multiply this one by 100. If you multiply this by 100, you are adding 2 extra zeros, so it's going to be 10 to the power of 21n plus another 2, and that's the final answer. In this question, I have a maximum point of a curve, and I need to find the image under these transformations. The first transformation is a translation by 5 units to the right, so the 4, 3 will become 9, 3. The second one is a stretch along the y-axis by a scale factor of 3. I am keeping x the same, and I'm multiplying y by 3, so I've got 4, 9. For part B, I have a transformation of the sine graph. I'll start by drawing on the grid the original sine graph. Now in the given equation, A multiplies the y coordinates by a number, and B divides the x coordinates by a number. If I take a point on the original graph, let's take the maximum point, the first maximum, it has coordinates 91, and the corresponding point on the transformed graph is this one here. That's the first turning point, and this one has coordinates 30 minus 2. So A, we said, multiplies the y coordinates, so to get from 1 to minus 2, it means that A has to be minus 2, and then B divides the x coordinates, so to go from 90 to 30, B has to be 3. In question 22, I need to solve this equation simultaneously. I'll do so by substitution, and I will substitute y with 2x plus 1. So I've got 2x squared plus 3 times 2x plus 1 squared is equal to 5. So 2x squared plus 3, 4x squared plus 4x plus 1 is equal to 5. 2x squared plus 12x squared plus 12x plus 3 is equal to 5, which gives me 14x squared plus 12x minus 2 is equal to 0. Let's divide by 2. So I get 7x squared plus 6x minus 1 is equal to 0. I can solve this either by factorization or completing the square or using the quadratic formula. I'll go on with factorization. So 7x minus 1 is the first bracket, x plus 1 is the second one. This will give me 2x values. These are 1 over 7 or minus 1, and each one of these will give me a y value. I will use this formula to find the y values. So I have y equals 2 times 1 over 7 plus 1. Y comes out to be 9 over 7. And for the second one, y is equal to 2 times minus 1 plus 1. Y is equal to minus 1. So my answers are x equals to 1 over 7 with y is equal to 9 over 7, or x equals to minus 1 with y is equal to minus 1. I'll start question 23 by finding an expression for this angle here, and because BCDF is a cyclic quadrilateral, this angle here is 180 minus x. The next thing I'm going to do is find angle C here using two separate methods. One of them to use the sum of the angles of this triangle, and the other method would be to use the sum of angles of this triangle, and then I'm going to equate the two expressions and get an equation which, when solved, will give me the value of x. So using triangle ACD, I get angle C is equal to 180 minus 54 plus 180 minus x. This is equal to 180 minus 54 plus 180 minus x. And if I further expand, I get 180 minus 54 minus 180 plus x, which gives me x minus 54. Using triangle BCE, I get C equals 180 minus x plus 32. If I expand, I get 180 minus x minus 32. So this will give me 148 minus x. And the two angles C have to be equal because they're referring to the same angle. So x minus 54 is equal to 148 minus x. So 2x is equal to 202. So x comes out to be 101 degrees. In this question, I'm given OA is equal to lowercase a, OC is C, A and B is 2C. I'm also given this ratio. So this is 3 to 1. There are total 4 parts. So this is 3/4 and this is 1/4 of the whole thing. So that's 3/4 of 2C, which will give me 3/2C. And the other one is 1/4 of 2C, which is equal to 1/2C. I'm also given that OQP is a straight line, and I need to find the ratio AQ to QC. Know that Q divides the lines OP and the line AC. Now, usually what we do here is we put a letter ratio, and we're trying to find these letters. So let's assume that AQ is equal to lambda. So QC is 1 minus lambda. I'm selecting these two, so when I add them up, I get 1. Similarly, OQ to QP, I'm going to put a different letter. I'm going to put mu and 1 minus mu. Again, when I add this up, I get the whole thing. I get 1. The mu's cancel out. And now the idea is to select a starting and end point and cover that in 2 different methods, equate the two, and solve somehow some simultaneous equations to find lambda and mu. Now I'm going to write 2 vectors that will be useful in our calculations. OP, which is equal to OA plus AP, and this is A plus 3/2C, and also AC, which is equal to AO plus OC. This is equal to minus A plus C. Now, the start and end points I'm going to select are O and Q, and I'm going to cover this in 2 different ways. One of them is the direct way going from O to Q, and the other one is going through A, so OA and then AQ. So the vector representing the blue one and the green one should be equal. So let's do the first one. OQ is equal to mu times OP, which is equal to mu times A plus 3 over 2 C. When I expand, I get mu A plus 3 over 2 mu C. And that's the direct way, that's the blue vector. Let's do the green one now. OQ is OA plus AQ. OA is just A plus lambda times AC. So this is equal to A plus lambda minus A plus C. Let's expand A minus lambda A plus lambda C. And I'm going to factorize the coefficient of A. So I get 1 minus lambda A plus lambda C. And this was the green path. Now, since OQ should be the same, it means that the coefficients of lowercase a and lowercase c should be equal. So mu should be equal to 1 minus lambda, and 3 over 2 mu should be equal to lambda. Let's write this down. Mu is equal to 1 minus lambda, and 3 over 2 mu should be equal to lambda. So if I try to solve this simultaneously, I can do this by substitution. I will get 3 over 2 1 minus lambda equals lambda. So 3 over 2 minus 3 over 2 lambda equals lambda. So 3 over 2 is equal to 5 over 2 lambda, which means that lambda is equal to 3 over 5. So now I have the required ratio. AQ to QC is equal 3 over 5 to 1 minus lambda, which is 2 over 5. And if I multiply this by 5, I will get 3 to 2. For question 25, I'll need to draw a rough sketch of the situation. Now, y is on a bearing of 280 from x and at a distance of 3.5 kilometers. Z is on a bearing of 220 from y at a distance of 6 kilometers. And we need to find the bearing of z from x, which is this angle here. In order to find this angle, first I will need to find the angle YXZ and subtract it from 280. There are some angles which I can find before start doing any trigonometric calculations. Now this angle here is equal to 360 minus 280, which comes out to be 80 degrees. Next, these two angles here are interior angles, which means they add up to 180 degrees. So this is 100 degrees, which means that the angle XYZ, which is this one, is 220 minus 100, which is 120 degrees. So now I can extract my triangle with the required information on. So let's start by working out the value of side y. I'm going to use the cosine rule, which states the following. And let's substitute the values from the triangle. So y squared is equal to 6 squared plus 3.5 squared minus 2 times 6 times 3.5 times cos 120. So y squared comes out to be 277 over 4. So y is the square root of 277 over 2. Since I know y, I can find the angle x by using the sine rule, which states the following. So sine x over 6 equals sine of 120 over square root of 277 over 2. So sine x equals 6 sine of 120 over this number. So x equals the inverse sine of this number. I'm going to put everything on the calculator. So x comes out to be 38.6 degrees. So the required bearing, which is the purple angle, is 280 minus the answer I just found, which gives me 241.4 to 1 decimal place.